Okay, please match these. Dicarbon dioxide. Dicarbon, 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 dicarbon dioxide. That's that guy. Carbon dioxide. That's that guy. Dicarbon monoxide. Dicarbon monoxide is that guy. CH4 carbon tetrahydride. Remember, H's are not hydroxides, they are hydrides. He's that guy. You got to learn these. You got to learn that 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona. I don't think you should know any more than that, but if you need to, 10 is deca. And we could keep going on and on. We're not going to do that. We're not going to waste your time. You've got to know how to do that stuff. So, yeah. Okay, predict products and balance. This is going to take a Kuhn's age here. So, let's see. This is iron is going to be with the sulfate. We don't know what this iron is charged, so that's as far as you can go. Hey, look at that. If they don't give you the charge of the iron, guess what you can't do? You can't come up with a formula for it. So this is thing number 26 in this review that stinks. I'm just being honest, folks. So I can't crisscross, so I can't balance, so I'm not even going to try. I'm just done with things trying to do mental backflips and stuff that's just not meant to be together. Okay, so then we trade partners. So Ca ends up with Cl. Ca is charged +2. Chlorine is charged -1. Crisscross. And then hydrogen ends up with OH. So we could call that water. This is +1. This is -1. So we're good there. Let's see. We have 2 OHs on this side, so we need 2 on this side. That's going to give us 2 hydrogens, so I'm going to give 2 there. That way I have 2 chlorines, 2 hydrogens, 2 OHs. I'm done. It's balanced. Okay, this is a combustion. Anytime I see a hydrocarbon and an O2, I should know that this is CO2 and H2O. And anytime you see that, whenever you see that happen, you should panic. No, I'm just kidding. You should, what am I looking for here? What am I looking for? Oh my god, this is so bad. 54, 55, 56. Okay, whatever. Anyway, it's CO2 and water. Whenever I see a hydrocarbon, I'm going to throw a 2 out in front of that, and then I'm going to start doing some atom counts. So I have carbons, hydrogens, and oxygens in a line, and carbons, hydrogens, and oxygens. And on this side, I have 4 carbons and 12 hydrogens and 2 oxygens. And on this side, I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens. I need this to be an even number, period. I just need it to be an even number. Since oxygen is by itself, I'm going to finish with it. But I'm going to throw a 2 out here. No. We can get it to be an even number. I have 12 hydrogens on this side, so I'm going to get 12 on this side. So I'm going to throw a 6 here. That's going to give me 12 of these. And then I'm going to have 6 oxygens plus 2 is going to give me 6, 7, 8 oxygens. And I need these carbons to be right. So over here I have 4, so I'm going to do 4 here. That's going to give me 4 carbons, and that's going to give me a whole bunch more oxygen. So I have 4 times 2 is 8, plus 6, 8, 9, 10, 11, 12, 13, 14. I have 14 oxygens. Now, the only thing, I have 4 carbons, 4 carbons, 12 hydrogens, 12 hydrogens, 2 oxygens, 14 oxygens. So I got to fix this. So what can I multiply times 2 to get 14? 7. Balanced. Done. That one wasn't that hard because there were no oxygens in your hydrocarbon. When there's oxygens in your hydrocarbon, it gets a lot trickier, right? Okay, again, single displacement. So I have a Ca, and it's going to be with this SO4 group. And again, the first thing you should do is identify cations and anions. I usually put them on the bottom. Second thing you should do is swap the cations or the anions, whichever you need to, and that's going to leave Ca out by himself. And third thing I need to do is look at the charge of calcium and the sulfate. And the sulfate is charged -2. And this calcium is charged +2. +2. So I'm good there. Those cancel. And now I just need to... What did I do? Oh my God, I'm an idiot. Jesus Christ. Y'all really are going to have to stay on top of me about this stuff. H2, hydrogen by itself. Calcium and hydrogen switch place. Hydrogen is by itself. This looks balanced to me, so I'm going to leave it at that. Let's try our luck with a double replacement. So K is going to end up with ClO3, and Sr is going to end up with CO3. And then I need to start seeing what everything is charged. Potassium +1. ClO3 is -1. Good there. Strontium is +2. And CO3 is -2. So I'm good there. And then I just need to balance. So I have two ClO3s here. I'll throw a 2 out there. I have 2 potassiums, 2 potassiums. 1 CO3, 1 CO3. 1 strontium, 1 strontium. 2 ClO3s, 2 ClO3s. I'm done. Oh, we didn't do types. Sorry. This is single replacement. This is a double replacement. This is a combustion. This is a single replacement. This is a double replacement. And this last one is a, what the heck? Oh, this is a decomposition. And all I need to do is balance this thing. So I'll put a 2 there. That gives me 4. 2, 4, done. The way I know it's a single replacement is I have one element on each side of this that is by itself, and it is a different element. A double replacement has 1, 2, 1, 2, 1, 2, 1, 2. Nothing is by itself. Combustion, anything that has O2 on this side and then products of CO2 and water. Combustion. Again, I have calcium by itself and hydrogen by itself, single replacement. 1, 2, 1, 2, 1, 2, 1, 2. So that's double replacement. And I'm counting polyatomics as it's a compound. It is something that is inseparable. That's why I count it 1, 2, just like it was an element. You treat it just like it was an element. And here we have one thing that is decomposing into 2 things, so therefore it is decomposition. We're in the home stretch, people. We're on page 9. Here we go. Predict the products and balance and classify each reaction. Well, you can't balance words. So I hate the way this is set up. You need to rewrite this whole thing. Aluminum phosphide. Aluminum is +3. Phosphorus is -3. So those crisscross, that's fine. Lithium chloride. Lithium is +1. Chlorine is -1, so that's fine. And they go to lithium phosphide plus aluminum chloride +3 -1. 3 has to come down here. +1 -3. 3 has to come down here to the lithium. And now I need to balance these suckers. So if I throw a 3 out here, that gives me 3 lithiums, 3 chlorines, 3 lithiums, 3 chlorines. I'm done. Pretty easy, right? Again, they're going to give me the same crap again. So if I have iron plus sodium nitrate and a nitrate NO3, I refuse to do it. I don't know what that's charged. I can predict products. I know that this iron is going to end up with this NO3 group, but that's it. That's where I'm pretty much stuck. Done. because I can't, without a charge, I can't do anything. And this doesn't give me any charge. So again, this is a dumb problem. Carbon tetrachloride. So I have CCl4 plus fluorine. And the anions are going to switch places. So I have CF plus Cl2. Remember, that's a diatomic. Carbon, since it's the cation in this case, is going to be plus 4. This fluorine is minus 1, so I'm going to have CF4 plus Cl2. And then I need to balance these suckers, so I'm going to put a 2 here and a 4 here. Oh, wait a minute, fluorine is a diatomic, so I'm going to put a 2 here. CCl4 plus 2 F2 goes to CF4 plus 2 Cl2. Ammonium carbonate. So that's NH4. And a carbonate is a CO3, and it is minus 2. Minus 2, so that's going to be outside of this. Plus lithium sulfide. Lithium sulfur. That is IDE, so it is a sulfide, so it is sulfur. That's minus 2 plus 1, so it's going to give me a 2 there. And then I'm going to go to ammonium, NH4 sulfide, and plus lithium carbonate. And since this is minus 2, that 2 is going to come down here. And since the sulfur is minus 2, that's going to come down here. So this is plus 1, this is plus 1. And it looks like it's already balanced. NH4, 2 of them, got 2 of them, 2 lithiums, done. Chromium 3 nitrate. Now this I can do. I can do this. Cr, which is plus 3, and a nitrate, which is NO3, and it is minus 1. And so that's going to be NO3 and plus potassium goes to chromium, and potassium is a potassium. My God, you're an idiot. Not a phosphorus, a potassium. So the nitrate is going to end up with potassium. That's going to end up potassium nitrate. Potassium is plus 1. NO3 is minus 1. So crisscross, done there. And then I need to balance, so I need 3 here and a 3 here, and then I'm done. When magnesium reacts with oxygen, what gas is produced? Show what, when magnesium reacts with oxygen gas, what is produced? That magnesium oxide. And magnesium is plus 2, minus 2, so it's that. And so they want us to show what happens to our electrons. I have 2 electrons. Oxygen has 6 electrons, so this can take both. So I'm going to put a double hook. He gets both the electrons. If problem number 63, if 25 grams of magnesium reacted with 30 grams of oxygen, how many grams of product are produced? This is a law of conservation of mass. So if I have 25 and 30 grams, and that's on this side of the equation, together that's 55 grams. Guess what I have on the other side? 55 grams. If you have 55 grams on one side, I don't care how you add it. If it's 25 and 30 or whatever, on the other side, you're going to have 55 grams of product. Using circles, show a diagram of polar, nonpolar, covalent molecules. Okay, you know what they're looking for here. They're looking for ionic, they're looking for nonpolar covalent, and they're looking for polar covalent, right? Polar covalent, nonpolar covalent, ionic. Intermolecular forces increase as viscosity increases. Intermolecular forces increase as melting point increases. Which as, love it, Which has the strongest forces, solids, liquids, or gases? That's ridiculous, but solids have the strongest forces. Rank the following molecules from strongest to weakest. Well, water is a polar covalent. Sodium fluoride is an ionic. Carbon dioxide is a non-polar covalent. How do I know that? Because we drew it earlier. It is symmetrical. On 2, there are no electrons on the same. So we're just putting these in order. 1, 2, 3, strongest to weakest. And that's bond, strongest to weakest. That doesn't mean that sodium fluoride is stronger than water somehow. That just means the bond in sodium fluoride is stronger than water. That means its boiling point is higher. That means its melting point is higher. All that good stuff. Okay, guys, I hope that helped somewhat. If it didn't, bring your questions in on Monday, unless you're in my first period, in which case you're going to be taking my exam first period. So I would recommend you come in before class if any of this doesn't make sense. Please don't send reminds for the mistakes I made in this thing. I know I made mistakes. I'm exhausted. But anyway, guys, good luck. If you need help, don't hesitate to come in Monday morning early. You know I'll be here. See ya.